Welcome to the arena. Think of your Cambridge computer science examinations not just as a test, but as an Olympic decathlon. It's an absolute marathon of 10 distinct disciplines, 10 unique challenges, and to take home the gold, or in our case, that A-star grade, you have to master every single type of question thrown your way. Today, we are focusing our energy on one of the most critical hurdles in the entire Cambridge AS and A-level Computer Science 9618 syllabus. We are talking about mastering pseudocode selection constructs, specifically if and case statements. Now, whether you're building foundational skills in the 0417, 0478, 0983, 0984, or 2210 syllabuses, or you're tackling the advanced 9618 paper, this is where so many candidates drop the baton. Let me introduce you to two very typical students. We've got Alex. Alex is a hard worker, but Alex overloads every answer with raw, unorganized computer science facts, just dumping syntax onto the page with zero actual analysis. And then we have Sam. Sam is fast, but Sam rushes the paper and completely misses the specific requirements of the command words. We look at their past papers side by side, and it is just a sea of red pen marks. Both of them know the theory perfectly, yet both are bleeding marks. Today, we're opening up the examiner's playbook to fix exactly that. So let's address the elephant in the room. Why is applying these concepts to unfamiliar contexts so incredibly hard? It's a huge frustration, isn't it? You sit at home, you memorize the exact syntax for an if, then else statement, you know precisely how a case structure works in your textbook, but then you get into the exam hall, the clock is ticking, the pressure is on, and the exam throws a totally weird, real-world scenario at you. Maybe it's a robotic arm in a car manufacturing plant, or a temperature sensor in a smart greenhouse. Suddenly, all that perfect logic just completely freezes up. Sam rushes and writes an if statement when a case was needed. Alex writes an entire page of definitions but doesn't actually solve the problem. This is the ultimate gap between having basic programming knowledge and possessing exam-ready problem-solving skills. The cognitive load just gets too high. But don't worry, because we are going to bridge that gap and transform those red marks into green check marks today. All right, here is our roadmap to mastering this discipline. First, we'll tackle the pseudocode challenge. Second, we'll unlock the method mark strategy. Third, we'll build your procedural framework. And finally, we'll navigate the top 3 examiner traps. Let's get right into it. Section 1, the pseudocode challenge, and how we actually meet Cambridge's academic benchmarks. To absolutely crush this exam, you have to understand exactly what the examiner's rubric is measuring. The assessment objectives for selection constructs target very distinct cognitive domains. It is not just about basic knowledge and understanding. It pushes heavily into application and critical analysis. When we look at a typical paper, there's a massive, glaring difference between an average response and a top-tier one. On the left side of your screen, you see what Alex usually does. Superficial breadth. This is just listing raw facts, dumping basic code, and hoping something sticks. You get no marks for just knowing what an if statement is. On the right side is what the assessment framework actually prioritizes: analytical depth and logical reasoning. Examiners desperately want to see that you understand exactly why an if statement is the mathematically and logically superior choice compared to a case statement in this specific scenario. They don't just want the end if or end case syntax. They want the architecture of your thought process. Section 2, the method mark strategy. This is the paradigm shift that changes everything. Okay, listen closely, because this requires a complete mindset shift. And honestly, it's the biggest secret to maximizing your score, even on your absolute worst days in the exam hall. We see this examiner alert year after year. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. When writing pseudocode, so many students, just like Sam, think it's a binary outcome. You either write code that compiles perfectly in your head, or you get a 0. But that is completely wrong. The examiners are grading your logical process. If your case statement has a minor syntax error or you forget a single otherwise clause, but your structural logic and working are clear, those method marks will absolutely rescue your overall grade. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, proving your logic is your safety net. You have to show them how you think. Section 3, procedural framework. Let's look at step-by-step algorithmic thinking. If we know that the process is just as important as the final answer to get those method marks, we need a bulletproof system, a procedural framework. Every single time you face a pseudocode question, you need to follow this 3-step sequence: deconstruct, solve, and evaluate. Top students use frameworks to structure their computer science answers perfectly. Think of the Peel framework from your essay subjects. Point, evidence, explanation, link. We can adapt that right here. You deconstruct the command words to find your point and evidence. What data are they giving you? Then you solve, which is your explanation, building the logic. And finally, evaluate, which is your link back to the specific problem. Do the alternatives work better? Could you have used a nested if instead of a case? This is the higher order critical analysis the examiners are literally begging to see on your paper. Let's break that overarching framework down into a granular, systematic processing sequence. This is the computer science success blueprint. Look at the screen and see if you can spot which step transforms a typical Alex answer into a top-tier response. Step 1. Identify key elements. Decode the command word, find the variables. Step 2. Apply relevant principles. Are we looking at a binary true-false choice or a multi-condition scenario? Step 3. Execute the analysis with clear working. This is where the magic happens, guys. This is where the red pen marks transform into green check marks right before your eyes. Show every step. Step 4. Verify your results. And Step 5. Present in the appropriate format using Cambridge-approved pseudocode terminology. If you apply this exact sequence, you are guaranteeing yourself method marks. Expanding on that blueprint, true algorithmic thinking means stepping back from the basic syntax and focusing entirely on the architecture of the problem. It requires step-by-step decomposition. It requires appropriate data structure selection. Should this be a 1D array, checked by an if statement, or something else? It requires efficient code implementation. And most importantly, and I cannot stress this enough, it requires rigorous testing. When you write an if statement, you aren't just jotting down lines of text. You are designing a logical funnel. Data goes in, and it gets sorted based on the conditions you build. If you don't test that funnel mentally before moving to the next question, you're leaving marks on the table. Section 4, Top 3 Examiner Traps. Pitfalls to avoid directly from the principal examiner reports. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome to our interactive workshop phase. We are diving into the principal examiner reports, which are absolute goldmines. They show us exactly where thousands of students, just like Alex and Sam, threw away easy marks last year. There are exactly 3 major mistakes that consistently trip up candidates when dealing with selection constructs. We are going to tackle each one with a specific challenge. If you can master these 3 traps, your mark potential shoots straight toward 100%. Are you ready? Trap number 1. Using the wrong formula or algorithm for the wrong context. This is the classic Sam mistake, rushing and using the wrong tool. You might write a beautifully formatted case statement, absolutely perfect, down to the end case syntax. But if the question required evaluating complex, overlapping Boolean ranges, say checking if a value is greater than 10 and less than 50 or equal to 100, you absolutely had to use an if-then-else structure. Case statements are terrible for complex Boolean logic. So here is challenge 1, the data scan. I want you to imagine a complex data table on screen detailing user access levels based on age ranges and subscription tiers. You have 60 seconds on the clock. Go. You scan that data? Do you use an I or a case? If you have multiple variables interacting, like age and subscription tier, you must select the I construct. Writing good pseudocode that doesn't fit the specific mathematical demands of the question context will cost you dearly, no matter how pretty it looks. Trap number 2 is an absolute heartbreaker, forgetting to check boundary conditions and edge cases. This brings us to challenge 2, find the flaw. I want you to picture a flawed sample paragraph of pseudocode, an if statement that reads, if sensor reading greater than 50, then trigger alarm. Now, audience, what is the flaw? I'll give you a second to think about it. Did you spot it? What happens when the sensor reading is exactly 50? The code does absolutely nothing. The logic falls right through the gap. Did you mean greater than or equal to? Examiners look incredibly closely at your greater than, less than, and equal to symbols. This is exactly where the method marks live. If you don't rigorously test the absolute boundaries of your conditions, your logic breaks down, the system fails, and your marks disappear in an instant. And finally, trap number 3, answers are not specific to the context given in the question. You absolutely cannot give generic textbook answers. Let's do challenge 3, speed writing. You have 30 seconds to mentally write one perfect paragraph. The exam scenario is about a temperature control system in a smart greenhouse. Go. If your pseudocode uses variables named X and Y, you just failed the application objective. Your variables and your analytical working must reference the specifics of the story. They need to be named something like greenhouse temp or sensor read. If you ignore the context of the greenhouse, you are showing superficial breadth, not analytical depth. You must tie the Peel framework, specifically the link stage, directly back to the context. That is the only way to prove you understand the scenario. So how do we lock all of this in under pressure? Here is a highly effective cheat sheet memory hack to avoid these traps: the visual story method. When you read the question, visualize the flow of data like a physical train on a track. An if statement is a simple fork in the road. The train either goes left or right based on the condition. A case statement is a complex switching station with multiple designated specific tracks for distinct values. By actively visualizing the physical structure of the data flow before you write a single line of pseudocode, you ensure you decode the command word correctly and pick the exact right tool for the job. Let's bring everything we've talked about together into our ultimate definition of exam strategy mastery. It is the continuous practice of deconstructing questions, extracting relevant data, rigorously testing those edge cases, and above all, showing all your analytical working with correct terminology to secure maximum assessment marks. This is the complete system: command word decoding, Peel framework application, and showing your work. Remember the golden rule: the assessment framework rewards logical, structured reasoning over superficial breadth. Prove your process, and the examiner will reward you. I want to leave you with a direct challenge to apply to your very next study session. Have you fully documented your logical steps and boundary checks in your latest pseudocode practice? Next time you tackle a past paper, I want you to pretend I'm sitting right next to you asking, but what happens if the input is exactly 0? Don't just write the code, write the logic, prove the process, and grab every single method mark available. Listen, students who implement these computer science strategies see an average improvement of 2 whole grade boundaries, but that only happens if they practice consistently with our weekly explainer sessions. Here's your final reminder: subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this with a study partner. Ace the Exams. Your Cambridge success starts here. Keep pushing that analytical depth, and I'll see you next time.